Right now, this very second, while you breathe, while you sit exactly where you are, the universe is tearing something apart. Somewhere out in the endless dark, a star is being ripped open and devoured. And the most staggering part is not that it is happening, it is that it already happened. 8 billion years ago. Long before the Earth existed, before the Sun existed, before there was a single ocean or a single living thing anywhere on this planet, a star died a violent death, and the light from the death has been racing toward us across the universe ever since, for 8 billion years, only to arrive at this exact moment in human history, so that you could witness it. We are not looking at a picture of the past. We are watching the murder happen. Right now. On the 2nd of July, 2025, just 2 days before Americans across the country would fill the summer sky with fireworks to celebrate the 4th of July, the universe lit a firework of its own. And it made every explosion our species has ever built look like nothing. This was the single most powerful blast humanity has ever recorded pointed at our telescopes. It did not last a second. It did not last a minute. It roared across the cosmos, screaming in the most energetic light that exists, for 7 straight hours, nearly twice as long as anything astronomers had seen in more than 50 years of watching the sky. And when the scientists finally understood what they were looking at, a chill went through the entire field of astronomy, because this was a way of killing a star that no human being had ever witnessed before. They gave it a cold, forgettable name, GRB 250702b, but behind that name is the greatest cosmic murder mystery of our time. A star is dead. Something enormous killed it. And to this day, nobody can agree on what. To understand why this single event sent a shockwave through observatories on every continent, you have to first understand the sheer, almost obscene power of what astronomers call a gamma-ray burst. These are the most luminous explosions in the entire universe, the most violent events to happen anywhere in the cosmos since the Big Bang itself. And here is the number that should stop you cold. In just a few seconds, one of these bursts can release more energy than our sun will produce in its entire lifetime. Think about what that actually means. Every sunrise you have ever seen, every warm afternoon, every ray of light the sun will ever cast across 10 billion years of its existence, a gamma-ray burst can match all of it, and surpass it, in less time than it takes you to read this sentence. They are so unimaginably bright that we can see them from clear across the observable universe, from billions upon billions of light years away, like a match struck on the far shore of an ocean so wide that light itself needs eons to cross it. This is the scale of violence we are dealing with. And on July 2nd, the universe produced the longest one ever seen. It began, as these things now do, with a text message. Astronomers around the world carry their observatories in their pockets. In a sense, when one of NASA's space telescopes catches something catastrophic, automated alerts fire off instantly, reaching scientists wherever they happen to be, whether they are asleep, at dinner, or standing on a beach watching the ocean. That morning, the alerts went out. NASA's Fermi Gamma-ray Space Telescope, orbiting high above the Earth, had detected a signal, a flood of gamma rays, the highest energy form of light that exists anywhere in nature, more powerful than the visible light your eyes can see, more powerful than ultraviolet, more powerful than X-rays. Gamma rays are a fingerprint. When astronomers see them, they know that something out there has just been destroyed in the most catastrophic way imaginable, very often, a black hole shredding a star to pieces, because only such events release this much raw energy in a single instant. So the scientists did what they are trained to do. They swung every telescope they could reach toward that one patch of sky, on the ground and in orbit, in a desperate scramble to catch the light before it faded, because a gamma-ray burst is supposed to be fast, brutal, blinding, and brief. On average, these flashes last somewhere between a single second and about half an hour, and then they are gone forever. This one did not go away. 1 hour passed, and the signal was still firing. 2 hours. 3. The burst kept pulsing out into space, again and again, refusing to die. 4 hours. 5. 6. And still it screamed. 7 hours after it began, this event, this thing that should have lasted seconds, was finally recognized for what it was, the longest gamma-ray burst in the entire history of astronomy, nearly double the duration of the previous record, which had stood for years. In the dry language of physics, it lasted around 25,000 seconds. In human terms, it lasted long enough for a person to fall asleep, sleep a full night, and wake up while the star was still dying. And this is the very heart of the mystery, because the two known ways a gamma-ray burst can form both have a hard, unforgiving time limit, and this burst shattered it completely. For decades, astronomers have understood that most of these bursts are born in one of two ways, and both are apocalyptic. The first is a collision. Two neutron stars, the impossibly dense corpses left behind when massive stars die, each one crushed down to the size of a city yet heavier than our entire sun, spiral into each other over millions of years and finally merge in a cataclysm so violent it warps the fabric of space itself, throwing off a flash of gamma rays that lasts a fraction of a second. The second way is a collapse. A giant star, many times more massive than the sun, finally exhausts its nuclear fuel, and without the outward pressure of fusion holding it up, its own core caves inward and forms a black hole in an instant. As the surrounding matter avalanches down into that newborn black hole, some of it gets funneled into razor-thin jets of particles that are blasted outward at almost the speed of light, and as those jets tear their way out through the dying star, they generate a storm of gamma rays. These are the longer bursts, and even these last, at most, only a few minutes. A few minutes. Not 7 hours. There is a ceiling built into the physics itself. Even a star spinning at the absolute breaking point, the very edge of tearing itself apart from its own rotation, can only feed a black hole this way for a few thousand seconds before it runs out of material. GRB 250702b smashed straight through that ceiling and kept going. Something was feeding this monster far longer than any collapsing star should ever be able to. So if it was not a normal collision, and it was not a normal collapse, then what in the universe was it? And here the mystery only deepens, because the gamma rays were not even the first warning. There was another eye on the sky that day, the Einstein probe, a satellite mission run jointly by China and Europe, built to hunt for X-rays. When astronomers went back and combed through its data, they found something that made no sense at all. The Einstein probe had caught a brightening in X-ray light coming from the exact same spot in the sky, roughly a full day before the gamma rays ever arrived. Now, understand why that is so deeply wrong. In every normal cosmic explosion, the sequence runs one way only. The highest energy light erupts first, in a violent flash, and then everything cools and fades, sliding down through lower and lower energies as the fire dies. This event ran backwards. The gentler X-rays came first. The savage gamma rays came later. The explosion was, impossibly, warming up. Nothing like this had been seen since gamma ray bursts were first discovered back in 1973. More than half a century of watching, some 15,000 bursts catalogued, and not one of them had ever behaved like this. One of the astronomers on the case, Eleonora Troja of the University of Rome, said it plainly: this made the explosion extraordinarily strange and exotic, probably something we had simply never seen before. The team now had a record-breaking duration, a sequence of light that ran in reverse, and not a single explanation that fit any rule they thought they knew. They needed to find the crime scene. What happened next became one of the largest coordinated manhunts in modern science, except the target was not a person, but a single point of light adrift 8 billion years in the past. Brendan O'Connor, an astronomer at Carnegie Mellon University, described the frenzy of those first days. Even on the 4th of July itself, while the rest of the country was firing up grills and setting off fireworks, the team was still hunched over their desks, writing frantic proposals, trying to aim every possible telescope on Earth and in orbit at that one patch of sky before the light could slip away. At first, they let themselves hope for something simple. Maybe, they thought, the signal came from inside our own Milky Way galaxy, because if it were nearby, it would not need to be nearly this powerful to look so bright, and it could be explained by some more ordinary, more familiar kind of event. That hope did not survive the data. NASA's Neil Gorell's Swift Observatory locked down the precise position. Then the Very Large Telescope in the Atacama Desert of Chile, one of the most powerful ground-based telescopes ever built, found the fading afterglow beside a faint smudge in the sky. And when the Hubble Space Telescope turned its gaze on that smudge, it revealed the truth: it was not a star in our galaxy at all. It was an entire galaxy, one that no human had ever catalogued before. Then came the James Webb Space Telescope, whose infrared vision can pierce straight through the thick clouds of cosmic dust that blind other instruments, and Webb delivered the measurement that changed everything. The light from this event had been traveling toward us for 8 billion years. This was no local flare. This was an explosion of such incomprehensible power that even after being buried behind vast clouds of dust in a distant galaxy, and even after crossing most of the entire age of the universe to reach us, it still lit up our detectors like a beacon. As astronomer Andrew Levin of Radboud University in the Netherlands put it, the event was even brighter and more intense than you might imagine, precisely because so much of its light had been hidden and swallowed by dust before it ever escaped. And now, at last, everyone agreed on one single thing. Whatever destroyed that star had launched a jet of material out of the wreckage at nearly the speed of light, and that jet is what generated the gamma rays we saw. But that one point of agreement only sharpened the real question, the question that still haunts every astronomer studying this event. What made that jet? What is sitting there in the middle of it all, feeding it? At this point, the investigators had narrowed it down to 3 suspects. 3 theories for how you murder a star and make it burn for 7 hours. And each one is stranger than the last. The first suspect is, frankly, one of the most bizarre scenarios in all of astrophysics, and it is the one the leading team quietly favors. Picture a black hole, but not one of the giants. A small one, what astronomers call a stellar mass black hole, weighing somewhere between 5 and 30 times the mass of our Sun, the smallest class of black hole we know how to find, each one born from the death of a single massive star. Now imagine this small black hole is not alone. It is locked in a slow, doomed orbit with a companion, a stripped star, sometimes called a helium star, a star that has already lost most of its outer shell of hydrogen and been reduced to a hot, dense core. For ages, the two circle one another, but their orbit is decaying, tightening, drawing them inexorably closer. And then the black hole does the unthinkable. It does not simply tear the star apart from the outside. It falls inside it. As the black hole makes its final orbits, it drags enormous streams of gas off the star, and the whole system begins to blaze in X-rays, which may be exactly what the Einstein probe caught, a full day early, the sound of the black hole beginning to feed. Then the black hole plunges into the main body of the star and starts to devour it from the inside out, gorging on stellar matter and blasting jets of gamma rays outward, until the star is finally ripped apart from within and explodes. And when the feeding is done, nothing remains of the star at all, only the black hole, a little heavier than before, drifting on through the dark. Eric Burns, an astrophysicist at Louisiana State University whose team laid out the evidence for this idea, put the wonder of it perfectly. Just the concept alone, he said, is incredible. This should happen somewhere in the universe, as absurd as it sounds, but it is not something anyone had ever confirmed actually seeing before. A star eaten alive from the inside by a black hole that crawled inside it. If that is what happened out there, then GRB 250702b is the first time in the history of our species that we have ever watched it occur. And yet there is a catch, because the perfect proof, a supernova, the scattered debris of the star's outer layers flung into space instead of swallowed, has never been found. The dense dust of that faraway galaxy, and its unlucky alignment with our own Milky Way, may have hidden the evidence even from the mighty Webb. The smoking gun, if it exists, is buried. The second suspect points to one of the most tantalizing gaps in all of astronomy. To understand it, you need to know that black holes come in sizes, and there is a strange, haunting emptiness in the middle. On one end you have the stellar mass black holes we just met, the small ones, a few to a few dozen times the mass of the Sun, born from dying stars. On the far other end you have the supermassive black holes, the true titans, which lurk in the hearts of galaxies including our own, weighing millions or even billions of times the mass of the Sun. The one at the center of our Milky Way is called Sagittarius A star, and humanity captured its first ever image only in 2022. But in between those two extremes, the black holes that should weigh somewhere between 100 and 100,000 suns, there is a near total void. These are the intermediate mass black holes, and they are so rare, so maddeningly difficult to confirm, that astronomers still argue over whether we have ever definitively found a single one. They are the missing link of the black hole family, the monster that theory insists must exist but that keeps slipping through our fingers. So imagine one of these rare middle giants, wandering alone and unseen through space, and imagine a star drifting just a little too close. The star in this version is a white dwarf, the cooling ember of a star that was once much like our own Sun, now at the very end of its life. As it strays near the black hole, the monster's crushing gravity does something horrifying. It stretches the star, pulls it, shreds it into a long, glowing ribbon of gas in a process astronomers have vividly named spaghettification. This is a tidal disruption, a quieter, less explosive way to kill a star than blowing it up from within, but no less lethal. And if that is what happened, it would be a scientific triumph, the clearest evidence yet that these elusive middle giants are truly out there. But Eric Burns is skeptical. The way the gamma-ray light flickered, the rapid, restless ups and downs in brightness that the Fermi telescope recorded, has only ever been linked to small, stellar mass black holes. There is a rule of physics beneath this: bigger objects respond more slowly, and a telescope simply cannot see a black hole flicker faster than the time it takes light to cross the whole black hole. GRB 250702b flickered on a timescale of about a single second, which points to a relatively small culprit. Comparing the two ideas, Burns said, felt less like comparing two horses, and more like comparing a horse to a unicorn. There is a third possibility, quieter than the others but no less strange. A stellar mass black hole may have shredded its own companion star in a glancing blow, a scenario known as a microtidal disruption event, the kind of thing that normally happens only with the giant supermassive black holes, scaled down to a smaller, more intimate stage. Eliza Nates, a researcher at NASA's Goddard Space Flight Center who helped lead the study on the black hole devouring a star, considers this more plausible than the unicorn, and she and her colleagues argue that the frantic flickering of the signal supports a shared conclusion, that a black hole merged with a star and then blew it apart. And here, if this is going to be an honest telling, is the truth about GRB 250702b, the truth that any real science story owes you, we do not know. The case is still open. The debate over the black hole's size, and the exact method of the star's execution, remains unresolved, and some scientists say there is simply no consensus, no single answer that everyone accepts. This one event has already generated at least 10 separate research papers, some of them published in the most respected peer-reviewed journals in the field, and still the world's astronomers cannot agree on the identity of the killer. Even now, as you watch this, they are hunting for fresh clues, studying the aftermath of the star's death in X-rays and in radio waves, hoping the fading echoes will finally surrender the answer. Jonathan Carney, a doctoral student at the University of North Carolina who led one of the studies, captured the strange joy buried inside the mystery. For him, personally, all of the different possibilities are equally thrilling. And maybe you are wondering, at this point, why any of us should care. An explosion 8 billion light-years away, in a galaxy we will never reach, of a star that has been dead since before the Earth was born, why should that matter to you, sitting here, on this ordinary day? Here is why. Every one of these events is a message carried out of the deepest past, because light takes time to travel, which makes every telescope a genuine time machine. When we look at GRB 250702b, we are not seeing the universe as it is, we are seeing it as it was 8 billion years ago, when the cosmos was barely more than a third of its current age, and we are, quite literally, watching history unfold in real time. And events like this one are how we test the outer limits of everything we think we understand, because every single rule this explosion broke, the backwards light, the impossible duration, the star consumed from the inside, is a rule we now have to tear up and rewrite. This is how science actually moves forward, not through the comfort of being right, but through the electric shock of encountering something that should not be possible. And there is a deeper reason still, one that hits closer to home than 8 billion light-years might suggest. Gamma-ray bursts are so ferociously powerful that if one were to detonate close enough to Earth, and aimed our way, it could strip away part of our atmosphere and devastate life across the entire planet, and some scientists have wondered whether ancient bursts may have played a role in mass extinctions written into our own deep past. So understanding these explosions is not only about distant galaxies and dying stars. It is about understanding the true nature of the universe we live inside, and the rare, cosmic dangers that share it with us. Because every single time we open a new window onto the cosmos, we discover just how little we truly understand, and that is not a failure. That is the entire point. So here is where we stand tonight. 8 billion years ago, a star was destroyed, something reached into it, or crawled inside it, and tore it apart, hurling a jet of matter into the void at nearly the speed of light, and for 7 hours it screamed in gamma rays, the longest death rattle ever recorded in the history of the universe as far as human eyes have seen. That light crossed an ocean of space and time so vast it defies comprehension, outliving the star that made it, outliving the galaxies it passed, and on the 2nd of July, 2025, it finally reached a small telescope orbiting a small blue world, where a young and curious species had only just barely learned how to look up and understand. And that species is still standing at the crime scene right now, staring at the evidence, unable to agree on what it is seeing. A black hole that ate a star alive from the inside. An impossible middle giant that shredded a dying sun into a ribbon of light. A companion torn apart in a glancing cosmic blow. We do not know which one is true. Not yet. Eleonora Troja said it best of all, every time we open a new window onto our universe, we realize we do not understand it, and perhaps that is the whole gift of it, a reminder of the sheer wonder, and the overwhelming grandeur, of the cosmos we are lucky enough to be born into. The star is gone. The light has faded. But the question remains. And somewhere out in that same endless dark, right now, as you breathe, another star is already dying, and its light is already racing toward us, carrying the next mystery, waiting for the moment, years from now, when it finally arrives, and we look up, and we begin to wonder all over again.